So, where previously we discussed about adders, VHDL coding, then data flow, behavioral structural model part. Also, we discussed about the multiplexer, demultiplexer. So, in that VHDL coding, we also discussed about data flow, behavioral and structural model part. Now, we are going to discuss about flip flops and then VHDL coding part. So flip flop, we know that it's a one-bit storage device with control circuit clock, and there are four types of flip flop. Is there SR flip flop and D flip flop, JK flip flop, toggle T flip flop. So SR flip flop, it's a set and reset flip flops. So this is basic black diagram for SR flip flop. Even we are using non-based SR flip flop. That's also shown in here, and then waveform. This is actually we going to only see coding part. I just showing what is about the black diagram and logic diagram. After that we will see about the coding. And D flip flop is a delay flip flop, so whatever the input you giving, the same input will be come to the output with the clock signal. Then the JK flip flop, so it's a JK flip flop. It is you So JK flip flop, it's a updation of SR flip flop. So SR flip flops that if the output is 1 1, so you can't use. It's a forbidden state we used. So previously you see that JK flip flop. So they're having forbidden state. So that's why they go to JK flip flop. They can overcome that trap back. And finally, it's a toggle flip flop. Toggle flip flop means it's a T flip flop. So in whether the input is 0, the output is 1. So it's a toggled one. So so these are the flip flop we already known in previous videos. And now we are going to discuss about the coding part, that flip flop. So this is I'm going to see about the SR flip flop. So this is basic diagram with a non gate, four non gate used SR flip flop, and one clock is there, and signal Q1 and Q2, and the output is Q and Q bar. And this is a truth table for a RS SR flip flop. So clock is the clock is high, then RS RR SR anything is same. Only. So R means reset, S means set. So 00011011. Then Q. So when it is 00, you'll be getting Q and Q bar. Then 1001. So when it's 0, so that is that is a reset. When it will be got 1, that is set. So I already said if it is both is 1, so don't care condition. So overcome that we are used to JK flip flop. So here the coding part of RS flip flop. So for behavioral model, they are used based on the truth table. So port, input port, and output port Q and Q bar they given. Then architecture, body of the program, RS flip flop. So body of the program, then header folder name. So begin process clock and RS. So truth table, we know that clock is there. So I already shown the truth table. See the truth table. So this is a truth table, clock and input RS and Q bar. So this is clock and R0 S0. Then you will be get the Q value is 0, Q bar value is 1. Similarly, else if so, what about the 0 1 and Q value and 1 0? What is the Q and Q bar value? And 1 1, what is the Q and Q bar value? So this is the basic program for uh, RS flip flop. And for structural modeling also they is shown in the program in RS flip flop. So any of the program is enough. This is structural modeling program. So entity is there, architecture. So then structural modeling they are calling that a NAND gate. We are this structural modeling. Um, so based on this logic diagram, they completed a structural modeling coding part. And next one is JK flip flop. So JK flip flop. So this is a diagram. So JK flip flop. So it's a simple JK flip flop. So the output connected to the input, and here also the output connected to the input. So JK flip flop. So this is a coding part. So first they used behavioral model based on the truth table. This is a truth table when it's 0 0 Q and Q bar 0 1 1 0 1 1. So this is 0 1 1 0 1 1. So this is because you know that forbidden state. They also give given Q and bar Q. So header file, we know that header file architecture and begin the process. So based on the truth table, flag is there 0 0 0 1 1 0 1 1. So JK flip flop. So again, it's a structural modeling coding part. And finally, it's a T flip flop. So T flip flop. So this is clock signal and connected to, so only one input will be given to the NAND gate. So for NAND gate used T flip flop. So this is a truth table. Clock signal is 1. T when it is 0, output is Q. When it is 1, output is Q bar. Toggle flip flop. So this is a behavioral model. So basically the clock at T0. T0 means output is Q is 0 and Q bar is 1. So this is T flip flop. And finally D flip flop also they shown. So D flip flop they have the one inverter and control circuit is that NAND gate. So this is behavioral model 0 0 0 1. So when it is 0 and the clock is 1, then what's the value? Q is 0, Q bar is 1. And D flip flop. Okay, so this is a coding part, and thanks for watching video.